Section 5, parallel lines. I can properly create proportions and solve them from, not form, information taken from parallel lines in space and triangles. So this whole section, his whole unit has been on creating proportions and solving with them. So here we have an example of parallel lines and transversals, and then our step really is to create proper proportions from it. And the nice thing is that when you have transversals cutting the same parallel lines, you have proportional segments created. So basically I can make a statement that says segment DE compared to segment AB, that ratio, is equal to EF and BC ratio. So this ratio compared to this this side compared to that side is going to have the same proportion, same ratio as EF to BC. And we can make that proportion and solve it. We have the same situation with triangles. When it's a triangle, we have two parallel lines. This creates a similar situation where we can say that BN compared to JK, so in other words, this side compared to this side, will be proportional to this side, NY, over JY. Notice my order. I went left to right in this case. You want to be consistent. So let's try some examples and see how they work. Here we have a triangle with two parallel lines. So we're going to make a proportion. Once we're in proportion form, I think we can solve quite well. So I'm going to compare this side right here, x, to this side right here. X over 15 equals, and then I'll go this side, 12, compared to this side, 10. We have our proportion created, we cross multiply, we get 10x equals 180, I believe. Divide by 10, and we get x equals 18. So again, trying to make proportions. Now, be careful on the proportions. Order matters. Make sure you do the same order for both fractions, otherwise that will mess you up. If you look at this one offers a unique situation, because if you notice, we don't have this side or this side. So that makes us look at this a little bit differently. And with this kind of one, I like to write it out to show you something, and that is to say there's two triangles present, the very large one, which is QSR, and that has lengths 20, that's right here, and then this side, which is 10. We compare that to this triangle right here, which is smaller but proportional, which is STU. The X refers to that side of the triangle, so that's a good clarification, and this is 6. So these are proportional, they're similar, so we can make a proportion, and I would say 20 corresponds with X, and I went left to right, so I want to keep that order, and then 10 corresponds with 6. Cross multiply these, and we get 10x equals 120, so x equals 12 if we divide by 10. So in this case we had to split them up because of the sides that they gave us. We had two pieces of the transversal of the parallel lines, but then they gave us the lengths of the parallel lines, and that caused us to interpret this a little bit differently. All right, let's try another one. With parallel lines in space, we have, as mentioned before, we can make a proportion of 15 compared to this side. It's going to be proportional to this piece. Again, I'm going from basically the upper right to lower left, so keep your order to 15. Again, I went this order. Make sure I do that consistently with both, and now I can cross multiply, and we get 10x equals 200 25, divide by 10, and we get 22.5. And this ends section 5, parallel lines.